welcome to the Iowa Grazing Academy. These are the recordings from the 5 online sessions that were held in July of 2026. If you have any questions, please contact Shelby Gress at the email address listed on the slide. Thank you and enjoy these sessions. Hello and welcome.
Today, I was asked to talk a little bit about paddock design and watering systems, just going through some very basic stuff on this. And when I was putting this together, I mainly talked about paddock designs without the virtual fence aspect that, is now starting to pop up and be a new craze in the grazing world, I guess I will call it. I don't know how much you guys have talked about that stuff, but anyway, going through with it, um, you know, got my slides working now too. So when we design a paddock and we design it conceptually, the most efficient for grazing, as far as the amount of fence we put in, is around paddock. That's, with a water tank in the middle. That's going to be the least amount of fence for that particular grazing paddock. If we have to do it all individually, that's how it is. Of course, we all know that that doesn't work very good in Iowa. That might work good if you were under pivot irrigation someplace, where there's going to be nothing growing in those pivot corners, kind of an aspect. But then we move on to the next most efficient is the square paddock design. Square paddocks, when we start looking at having multiple paddocks, we start becoming more cost effective with our fence, because our fence now is going to be supporting more than one paddock, especially when we get into permanent fencings in those situations. That fence is there. We can go ahead and use it when cows are on both sides of that. Whereas with a round paddock, that's not going to work for us. Moving on down, the next most efficient for grazing is going to be rectangular paddocks. We're going to have less forage available, than in a square paddock, at one time. But it does have, some advantages. And a lot of people like using rectangular paddocks, especially certain times of the year. And they work great for taking square paddocks and subdividing them. So they work really good with our temporary fence systems, things like that. Another advantage to the rectangular paddocks that people sometimes use is that they put the water on one end and they put something else, whether it's shade or minerals, at the other end, and have the livestock going back and forth between the two to make sure that they get across the entire paddock. And then, the last thing in our paddock designs conceptually is what we live with in reality here in Iowa. We have to fit the obstacles that we have out there. Most of our pasture grazing land, we're going to have streams. Some of it we could have some terraces on where somebody has converted stuff. We're going to have ravines out there, gullies, those kinds of things, cliffs that we're either going to, have to try to fence through or fence around them. And anytime we're trying to fence through that stuff, we all know it's going to rain and that's going to affect us. So paddock designs, when I first start thinking about it, I'm going to try to get as square as I can. But then again, we're not out here in some flat square landscape where we can do that real easily. And if we were flat and square, in Iowa, most of it's going to be converted over to row crops. Next one here, just wanted to talk about the design. Make sure that we're doing this with permanent fence. It can be subdivided with temporary fence later. We want to really work at that aspect, and it takes some time to get this stuff really done. One of the best ways to think about paddock design, whether it's permanent or temporary, and the water placement going with it, is having multiple people look at it and draw up ideas, and then you can use each other's ideas of, hey, this is a good idea to add in, or well, there's the problem with that one that you never thought about. And oh, yeah, you're right. I never did think about that. So when we're doing this, having 3 or 4 people that, you know, have been on the ground helps a lot. Been thinking about it for a while helps some, but it does help you to come up with a great idea because everyone we do, we're going to come up with something like, oh, I should have done that a little bit different here or a little bit different there. It's one of those things, just like having a perfect grazing system, getting the perfect fence design, usually doesn't happen. So, next up, just wanted to hit a little bit on the water placement for these systems. That's really important when we're designing the paddocks, and how we get that water, which I'm going to talk about later in the water section on this, is really important aspect of that. So we'll be covering that part. But early on here, the thing I really want to cover is we prefer to have a distance of less than 800 feet for water from any place in the paddock. That's just something that was some work that was done down in Missouri. And this is a graph showing what happens with it. And just to talk through this a little bit, our pasture utilization, any grazing event that we're in, we want to remove about 50% of the forage. So when we look at this, and that's what our pasture utilization rate percentage is over on the left-hand side. So in that first 100 feet, we're up to about 70% utilization from that water tank. And that makes sense because, somebody's getting a drink, somebody else might be going and taking a bite of grass off that area right there around that. Then as we move out from there to about out to 300 feet, takes us down to here where we're about 50% utilization that they were aiming for when they were doing this study. And then we have that nice level line going across there that we get out there about 700 feet, staying right there at that 50%. We get out to 800 feet, it's down to about 45%. So we're still pretty close right there and making sure to utilize that forage efficiently. But as you can see, it really starts dropping off there. So, when we get out there past that 800 feet, we get out there past 1100 feet, and we're utilizing less than 10%. So, and to put that in perspective, a quarter mile's 1,320 feet. So if the cattle are walking that far, they're probably not going clear back to the back corner of that pasture. So we need to make sure to be thinking about and trying to get the water available out there, as best we can. And as I've told people I've worked with, I've not been afraid to put 2 water tanks in the same permanent paddock. Just helps makes things easier in the future for if you want to try to do subdivisions in the future, and just to make everything work. So there's a lot of differences that can happen in this, and you just have to work your way through them. Next one I'm going to touch on here is, permanent paddock design, and I'm going to have a couple of charts showing them. But we need to determine the number of permanent paddocks we're going to want. And in today's world, if somebody's willing to jump on the virtual fence, we might just be down to 1 permanent paddock. We have lots of people who are running temporary fence that just have 1 paddock kind of a deal. But a lot of times we are dealing with things where we have the creek running through there. We want to fence off of the creek, the floodplain around the creek, and have that be its own separate kind of a paddock. Those are important things to come into as we try to do this work. But when we do our paddock design, we want to determine the number of permanent paddocks we really want to work through there. I'll show those slides later. But, we always have the temporary fence that we can subdivide it. But we really need to figure out the number of days we want to spend in each paddock grazing when we're doing this. So one of the aspects on this is, how long do you want to go with, until you're moving animals? And I'm sure we've talked about this a lot, this already, how long the cattle are going to be there, and then how many days of rest do we need until we regraze that. For the most part here in Iowa, we say with our cool season grass pastures, which majority of ours are, we want to try to have 30 some days of rest going in there for majority of the year. We may have to go a little shorter, um, early in the grazing season when that stuff is really growing fast. And we may want to slow down later on in the year when we get to this time. We haven't been getting any rainfall events, at least in the part of the state I'm in. And the grass is starting to slow down. We may want to be slowing down that grazing as we go through it. Um, big factors to consider are forages present in the paddocks. As an example, we want to go a little bit longer. If we have native grasses in the paddock is where we've been with this. Let them have a little bit more recovery to make sure they get back up. And then another aspect that we need to think about when we're doing permanent paddock design is, if we're going to be haying it on occasion, when that grass gets ahead of us, that helps us out a bunch. Um, we need to make sure to be thinking about putting that stuff in so that we can get the equipment through to those paddocks. All different aspects, which ones will that work better on, which ones will they not? So moving on here, here's just a simple paddock design. We have 4 paddocks out here um, with a central water tank. This is a simple setup that could be done. As I said earlier, with our 800 feet to water, if we would look at this conceptually as a square, um, we could have about 10 acres in each paddock. That would be 40 acres here total. So we're looking at a quarter mile on each side of those as we're coming through, 660 feet coming through. That's a very simple paddock design that we could start off with when we start working with somebody on a small scale on something like this that we can go ahead and get designed. In theory, we want to wait 30 days here to come back in and regraze that paddock that we were previously on. With 4 paddocks, we would figure 10 days in each paddock to do that. Spending 10 days in each paddock, 4 paddocks there, it's going to be 40, but we take the 10 days off for the one that we are currently in. So we're going to have about that 30 days of rest. So that's kind of where we can go with something like this. Moving on to the next one here, we're showing something where we have 8 paddocks shared between 2 tanks. And this is something that could be done very easily on an 80-acre kind of deal. Kind of the same thing here. We end up running through here. So if we have 8 paddocks and we want to have about that 30 days of rest here, we need to take the 30 days and divide it by the 8 minus the paddock they're currently in is 7. So we're going to be just over 4 days in each paddock. So if we turn around and run that again, let's say we are going to run them 5 days in each paddock. 5 times 8 paddocks is 40 days, plus you take off the 5 for the day they are in. It's going to have 35 days of rest coming through, something like that. So we're getting into a little bit more rotation. One thing I do want to mention on this is our rotations should not be just based on days. We really need to be looking at that grass and deciding if we need to be speeding things up, slowing things down, or making some more forage available to those animals. Next slide I'm going to show here is, going up to 12 paddocks and, just kind of having the 3 tanks out here. Again, this is in a nice, flat, perfectly square world where we can do something like this. But in this situation, we would be about 3 days in each paddock. If we take the 12 paddocks minus the paddock they're in, that would give us 11. 11 times 3 days in each would take us to 33 days. Starting to get into more intensive systems that we can do that. The nice thing about all of these is we can keep subdividing each of these paddocks, especially in something like this. If we wanted to get more intense, we can subdivide and then let them trail back to the water for a little bit in something like this. So maybe one of these paddocks here of these 12, we could split it apart in thirds and give them the front third, then the middle third, and the last third. We could have a laneway coming back to the water if we need to in those situations, or we can just let them walk back across the stuff that they've already been um, grazing. So, like I've hit on before, paddock design issues, streams, floodplains, gullies, steep hillsides, those all make it so that we can't do anything like we just showed going on with, those very simple designs in the square world. One of the other issues is where water is currently located. That causes a lot of problems with trying to get things figured out where water currently located. Of course, we can potentially move that water. May take some effort, some cost, and some engineering to try to get that done, but we can move the watering facilities around to different places if we decide that's what is needed. And of course, with that, when we're doing paddock designs, we're probably going to be needing to add more watering facilities out there for the cattle to go ahead, or whatever grazing animal you're utilizing out there to go ahead and use for drinking, because we can throw sheep and goats, horses in as well. I'm mainly looking at this from the grazing animals as far as ruminants or horses with the pseudo ruminants. And then the last part is how to get that water where it will be needed. We need to get that water out there so that those animals can use it at the time of year that they're going to need it. So, if we're going to be doing some winter stockpile grazing, we're going to be looking at this a little bit differently than if we're looking at something that's just straight only summer grazing pasture. So, next slide, I just wanted to hit on a little bit the virtual fence. That's going to give us unlimited options for designing the paddocks. We just have, either using base stations, cell towers, internet, satellites, going ahead and telling those cows where they are supposed to be and where they're not supposed to be as they're out there eating it. So, talking about that, it's a great opportunity to look into and chat with some people about, if you're not very far along with a rotational grazing system, or if you think it will be advantageous. It does have some considerable expense going into the virtual fence that does limit it, but it's one of those things that's worth looking into. My guess is we're going to continue to see more and more of it and have more opportunities, and the costs will continue to go down. So moving on to watering systems, here's kind of a winter watering system going on. They have some areas fenced out for some reason, but you do have the creek flowing right through the middle of that. Probably that is not the best watering system, feed system right there next to the creek, from NRCS standpoint, with wanting to try to keep our waters clean and trying to have some good forage available and filtering of nutrients before we get to the creek in our pasture systems. So our watering systems, we need to determine the animal needs. I'll talk about that here in the next one. The quality of water for the animals, placement of the watering facilities, size and shape considerations, and just things to avoid. And that first picture was something to avoid. So the animal needs, I'm going to say it this way: on a hot day like today, more is better. We really need to think about not just the bare minimum that a cow might need to make it through the day. We want to go ahead and look at, how much do they really want. So, and one thing, we used to talk a lot about how 20 gallons per day was all they really needed. As our cows have been or I shouldn't say all of our cows, as majority of our cows are becoming larger, we're kind of moving up towards that 30 gallons a day. And if you ever want to know how much your cows need to drink, just haul water to them sometime and you'll figure out really quickly how much they really need. I do think a lot of that has to do with there was a formula I heard at one time that a lactating cow needed 2 gallons per 100 pounds of body weight. So, as we get up to, 1,500 pound cows, and some of them are getting more than that, that does fit in with that 30 gallons. Whereas, when we figured the old 1,000 pound cow, the 20 gallons did fit. So, as the cattle are getting larger, we're probably working more up into that range. Dry cows, we're still in that same needs. Not as high, the 10 to 20 gallons. It may be 10 gallons or less during the winter time, but on a day like today, if you had a fall calving herd, I'd sure be wanting to give them a little, make sure they have available that 20 gallons of some water that's at a good temperature to go ahead and help them out. Sheep and goats, we don't really have a lot of information on it. Information that has been pulled tells us they're somewhere in the 1 to 4 gallons per day. It may be, and quite often is, less than 1 gallon a day that they need, depending on what they're getting from the forages they're eating. And the last animal I really wanted to touch on was the horses. If we have horse grazing system, which we don't have too much of that in Iowa, they're looking at the 10, 15 gallons per day. Quality of water. So, I hit it down here at the bottom. Most of our sources are usually going to be sufficient water quality. We don't need to have as good a water quality as is required for us for human consumption going on. For example, they can have a lot more nitrates and other things in their water than what would be allowed to be sold to us from a municipality water supply. So, sources of water, I put down rural water, any municipal water, that is going to give us a good water source out there with a pressurized system that we can go put water out there in most places on our pastures. The next one I have listed is a well, which, wells work great in, at least 50% of the state, probably a little bit more than that, where we can get some good quality well water tied in there, and we can, again, put that water out there where it needs to be. That's going to take some work. We're going to have some upkeep that we have to deal with, compared to the rural water. But we're either paying with well, we're going to just be paying a little bit on an electric bill compared to paying for that water year round that we have to do when we get the rural water. The next two there go together: streams and creeks and ponds. We can water out of streams and creeks. Different parts of the state, again, we have some good water there. We don't want to do that too much, trying to keep the animals away from the streams or limit their use of those stream areas. And if we do that, it's nice to put in some armored area so that they can get down into it and not be causing too much more problems with the stream banks getting into those. Ponds are very popular in parts of the state here where we have the topography that will support them. They don't last forever, which of course our wells aren't going to last forever either. But the ponds are an expensive upfront option that we can go ahead and get some water put in. One of the biggest problems, from my opinion, with ponds is we're limited in that we can't get water much higher than the toe of the pond. We have water coming in, so we can't water. If our pond's on our property, the ground above that, we can't really get to put some water up on top of that ridge where we typically have better water growing, except for if we put some kind of a pressurized system in on those. And then again, that's bringing in more uptake than just letting gravity flow our water out of our ponds down to our watering facilities. Springs are also available. They are usually fairly good quality. Our biggest problem with utilizing springs is if we try to do a spring development from it, sometimes we end up, you know, causing the water to no longer flow there, and then the spring dries up, and then we are out. So those are sources that we can get for water. We kind of start off, the top two are usually going to be the best sources. Cow-calf operations, we're not too concerned about making sure to have the best quality water available to them. We just need to make sure that it's good enough, which, can simply do some water testing, get that sent in and have that tested to see where it is. Next up, the placement of waters. We always like to place them on high ground or elevate them to improve the drainage around them. Even when we're below a pond, we're putting in a new water tank, a new pond and water tank down below that. Take the time and build it up a little bit on that heavy use area that the cows are going to stand around, so they're not standing in the mud. It has a chance for that water to run off or limit the amount that it is. Also, anytime we're doing permanent waters and, with temporary water tanks, we can also do it, but armor the soil with concrete or rock, just to keep from the cattle. They slop water out of that tank, and then they end up tracking through it, and they end up walking some of that dirt away from that area. If we go ahead and we have concrete around there or rock, we're not going to end up walking that stuff off. Another thing that we need to think about is we are limited by pressure to flow water. So, if we're getting into some place hilly and we have our well and our pressure plant down at the bottom of the hill, and we need to go 200 feet up a hill. Sometimes we do run into trouble there with having to be able to get the pressure to flow water all the way up there. Most of the state, we're not going to be running into those kinds of issues, but it is something to think about that, hey, we might be only able to take the water this high and not to the top. Last thing I wanted to think about on placement of waterers, it really works good on tops of ridges. That way cattle can see them from both sides, and they can go ahead and get a little bit of summer breeze when they're up there. And again, like I touched on earlier, a lot of times we have our better forage protection up there on top of those ridges than we do on the side hills, kind of a thing. So if we can have water up there, that helps to get those cattle up there, especially if the other end of it's down by the creek and we have shade down there. I've seen it where the cattle, haven't gone up and grazed some good grass on top of the hill just because it was too far up there from their aspect to go ahead and get it, and they were regrazing short stuff around them. Moving on to tank needs. There's two ways to go about this. We can either have a large tank that will hold 1 day's worth of water, where we will have a slow recharge rate. When I say a slow recharge rate, we're talking 2 to 4 gallons per minute, maybe even less. When we do that, we have smaller pipe, less pressure, limited flow. All of those factors come into doing that with a large tank. On the other side of it is having small tanks. When they don't store much water in them, we're going to need the faster recharge, which could be requiring larger pipe diameter on the water, going to that water source. More pressure we're going to be dealing with when we're dealing with those, and we're going to need to have a system that's going to give us a good flow. We could be up there 20 gallons per minute or more in some of those situations. So we may not have that from our wells. So that's something where we do some engineering work and work through these to really figure out what's going to work best to give your cattle the water that they need to work, that they need to get through while they're grazing those pastures. Just going to show some examples of different systems and talk through some high points and low points of them here going through. Here's a very simple system here. Somebody just took a water tank, got a garden hose coming off of there, hooked into a hydrant or something. Obviously this is a situation where we're moving it quite regularly. When we do get into situations where we have small ones, we're usually pretty close to the water tanks. So the cattle will be able to drink individually. In this situation, we might be able to get 3 or 4 around that tank at one time drinking from it. If they are drinking about 2 gallons per minute, we're looking at about 8 gallons. We typically look at a recharge rate on a float valve in a situation like that of maybe 4 gallons per minute. So they can be taken a little bit, but by the time we move around, as we can see, there's only one drinking, one standing there really close. The one that's drinking is actually behind the one that's closest to the front of the tank there, and then you have the one that's over top of the two of those. So just kind of showing you how that works. Real great option for somebody that's into an intensive rotational grazing system to get that water moved around wherever they want to move it, as long as they're close enough to a pipeline system to supply it. Here's kind of the other end of the deal. Fairly big water tank here. This is an old construction tire that they used for the tank here. The system is set up, quite a bit of storage there. We cut the availability of water off to only half the herd can be, only half the tanks available to drink out of. So, that's one of the advantages. This system will work really good if we had slow flow, if we were limited to 1 to 2 gallons per minute coming into this. In this situation, we'd have a lot of water available there. We probably would have close to that full day's worth for the herd that's out here in this situation. Another advantage of these things is they seem to do really good going through winter, just leaving the water in them. It freezes up and they come through fine in the spring when the float's down in the bottom of them. So, and people have actually taken them and just went ahead and hit the edges of them with a tractor or a skid steer, something like that, to try to get that ice to break up. They are resilient. So nice ones to use. Here's another situation that's similar to the first one that I showed here. This looks like we have some dairy cows out here grazing in this area between the creek and this fence. One thing that they are doing here is that they are limiting so that they can only get to about half of that tank. I don't know if they're trying to protect the float in this situation, but again, it's something where it looks like we're pretty heavily high density situation going on here. Uh, as I said, it looks like we have dairy cows here. I don't know if they're dry or not, but if they're going back to get milk, they're going to be getting water or getting milk or getting water when they're up there at the facilities there as well. So an opportunity here, fairly short distance. So we just have a few drinking at a time. Another one set up kind of the same deal. We have the line coming in from the bottom. We have the float sticking up there. It kind of looks like the poly wire running across the top of the tank is on the tank, but I'm sure it's above. Otherwise, we'd be grounding it out. But just a very simple, cheap alternative that you can do, and you can see it's going to be moved, daily kind of thing, and we can see where the animals have been up there close to it, drinking out of it here before they've went off to continue to do more grazing. Here's another one, this is going back to a few years ago. We were putting in the uh, frost-proof tanks like that in the backside of a pond in this situation. This one is interesting because they figured out that they didn't have enough headspace there, so they brought in the oval tank and put over there beside it during the summertime so they can go ahead and have more cattle water at the same time here, instead of being limited and potentially animals not getting to the water. Then yet they still have the opportunity in the wintertime when they don't need as much water. We have the frost-proof concrete tank sitting there. The other system can be disconnected and we will still have that available to us to use during the wintertime. Here's a system that was set up where somebody just took the old running gear and they put an oval tank in there. They got a pretty hefty hose leading to that. They got the mineral sitting right on there, but they just set that up. They got the fly control things hanging there as well. Something very simple set up to go ahead and move around to get them. That's one of those systems, need a little bit of line there. And as you can see, they got the bar up across the back there so they can hang the line running to it that they're hooking to their water line, their pipeline someplace else to go ahead and move that around. But that's a very simple one. Don't know how much of a side-by-side or UTV, with a full water tank on there. You might have to drain that out to move it, or might need a bigger UTV. So that's something to think about on some of these systems like that, is how are we going to make this stuff move. Here's another. This is a fairly nicely set up using a old tire kind of thing. The only problem I see with this one is those look like cabs. We seems like it's sitting a little high for me. We want to be 24 to maybe 26, 28 inches for the top of the tank. And this one looks like we're getting up over that, maybe 30, 36 inches, somewhere in there where those calves can barely put their head over that. So something to think about, and make sure that you put the tank in for the smallest animals that you need to be able to get to that. So, if we had a cow with a 3-month-old calf out here, that calf might not be able to get in and drink the water. Now, granted, it has mama's milk that it can be getting its hydration from, but they at some point they need to be learning to drink out of the tank too. Here's another one of those big tanks. This one's actually a steel tank that was put together. And if you look over towards the left-hand side there, you can see where something has caused it to get bent in over there. I don't know if it was an animal, a vehicle, or what. But after they ran into that problem, they've put some cattle panel rounded around in there to try to keep the livestock out of the middle of it. This situation, looks like they have a fairly big tank and they don't really have a float going into it with that water line going in there, where they just turn it on every however often they need to go ahead and get water into that paddock. So here's another one that's set pretty good. It's set in the ground quite a ways, and then they have some nice steel going around it to help protect it. Even have another little pipe sticking in over the middle of it to help protect the float valve so the animals don't knock the float, and then it ends up running over. And seeing how long it goes and looking at this, it looks like it could be out more on a rangeland where this one was done, but just another option out there for the tanks. So that's what I was going to go through today. And Here are a couple of sources that I use. These came from Missouri NRCS, electric fencing for serious grazing and watering system for serious grazers. Those are the URL addresses, which should be available in the slides later. So